What is SIP security? When we talk about things like SIP safety, SIP sync, these are protocols built on top of SIP. SIP is Common Industrial Protocol, used by Ethernet IP. It was actually also used by DeviceNet and ControlNet. It was just over different media protocols. Ethernet IP is just SIP over Ethernet. So we talked about the evolution of automation. We always prioritized availability and speed. And when we expose that over Ethernet, then all of a sudden we have unsecure protocols sitting on our main networks. And there's danger and risk associated with that. So what SIP security does is instead of always prioritizing availability and speed, it allows users to prioritize speed, integrity, how good is the data that's going back and forth between the devices? Can somebody sit in the middle and affect it? And is the data confidential? Let's say that this is Coke's secret recipe getting sent across the network. That data is extremely valuable to Coca-Cola, and making sure that no one can read that is extremely important. Whereas if I was just sending a command to a variable frequency drive to turn on and turn off, it might be important that somebody doesn't manipulate that data, but I'm not so concerned that somebody can't see it. If they see it, it's not as risky as somebody sending an off when I wanted to send an on, or vice versa. So how this works, this is not in all of our devices yet. So this is more of a, it's coming, it is here in certain devices, and it will be spread across more devices as well. So highlighting a few devices that do have this operation. So the L8 processors, the EN4T module, the PowerFlex 755T drive, and the Kinetix 5700 are capable of this inherently themselves. There are gateway products that can allow other devices to follow in the system, but devices that can natively do this are listed here. So it actually gives us a few powerful operations. If we highlight the communication between FactoryTalk links and the Ethernet module, what we want to do is we want to verify that we're not having somebody that's not actually our system and our FactoryTalk links to communicate with our devices. So it's going to generate certificates, and the certificates are going to actually be passed back and forth to verify and authenticate who is trying to communicate. So now we know who's communicating, we can start communications. That's one level. However, there are still ways that someone could actually sit in the middle of that connection, and it might hear what one side wants to do and send something entirely different to the automation system and then affect our automation system. So certificates provide one way, but there are still attacks we would be exposed to. What you can do is you can do integrity checks. So integrity checks are going to include some additional data with the packet, and that data is going to be a way to verify that no changes have been made to it. So a hacker can now, they can't get in the middle and change the command going to the drive. They can't turn the drive off when we wanted to turn it on. It would be detected, there'd be an integrity conflict, and it would actually drop the packet. But the hacker can still see it. So if we were really concerned about whether or not our data was completely protected and encrypted, so unable to be seen, we can do something called confidentiality, where we actually encrypt the traffic going back and forth. So once it's encrypted, not only can a hacker not see what's happening, they can't change it, it's very protected data. With that though, with encryption, so you have to encrypt it on one side and then de-encrypt it on the other side, there's going to be a speed change. So you are going to lose some speed when you make a change like that. So what you get to do within SIP security is there's a policy manager. So policy manager allows you to dictate what devices should be able to communicate to each other through different avenues. It calls those zones. So zones are devices that can communicate, and then conduits are how they communicate to other zones. You can actually also detail what type of security you want with each of your devices. So if you want to have, if speed is your biggest concern and you're not as worried about the data itself being encrypted, you don't have to use confidentiality. So you have the ability to dictate what is and isn't used. So here's an example. If these devices are all allowed to talk to each other, you'll see in some cases, I'm utilizing certificates for each one. On one of them, I have my data confidential. On the others, I'm using integrity. So I get to pick what is and isn't going to be implemented here. And then you can whitelist devices as well to allow the communication. So once you set up your system, you can break it into various zones. Now, zone 1 and zone 2 are not naturally going to talk to each other. So you can actually protect each zone from talking to each other and actually just have a conduit up to our main system. So zone 1, devices can freely communicate. Some of them have confidentiality. Zone 2, we've set up entirely differently. These are all just based on integrity. There's no confidentiality built in the zone. And then with the conduit, we actually allow it to talk to the main system. So this is growing. This is going to be more and more common as more and more devices are exposed to it. It's also, like we said, going to have a gateway. And in that gateway, you can actually take a device that might be an older device. So you might have an older system where you want this level of security, but you need to hold on to an older automation device. What you can do is that you can actually have a SIP security device that's going to protect the device behind it and sit right in front of it for this level of protection. So it's coming. A few devices are here. This is going to grow even more over the next few years as more products have it natively.